So guys, in this video, we are going to learn about operator precedence parser. In one video, I will cover more OPP with an example, which will be good for the upcoming exams. Operator precedence parser need to be operate in operator grammar. What is an operator grammar? Operator grammar should not have any null production, and it should not contain two adjacent non-terminals. Which means this grammar which contains EB and BE as two adjacent non-terminals is not an operator precedence grammar. To convert this into an operator precedence operator grammar, we need to expand this B inside E. This will become E extends to E plus E, E into E, and E is equals to B and ID. This is an operator grammar. Now you might ask that this is an ambiguous grammar. So operator precedence parser is the only parser that allows ambiguity in it, and no other parser allows ambiguity, but operator precedence parser allows ambiguity. We will see further why. So now we will see how to solve an operator precedence parser question. This we will solve this question in four steps. First step is operational relation table. Second is operation table. Third is function graph, and fourth is function table. Now this is the given grammar and this is the given string. The string says ID plus ID star ID. For this string, we have to create the operation relation table. How we will create that? We'll just create a table and put non-terminals over left and right. Now this is a left recurrent grammar, so left non-terminals will have greater precedence with the same signs like plus and plus. So left plus will have greater precedence. The star has greater precedence than plus, so we'll put a greater than sign towards the star. ID has the greatest precedence among all, so we'll put greater than sign in ID for every sign, excluding the ID sign, because ID in ID will put a dash, and for others we'll put just a greater than sign to ID. Dollar has the lowest precedence, so we'll put greater than sign opposite to the dollar for every single sign. And for dollar dollar, we will just put an except. Now for a star has greater precedence than plus. Star has greater precedence than the right star. And for ID, we have solved early. So this is how you will create an operation relation table. Now we'll see what operation table or syntax table is. Now we will create operator table. For this, we have to take stack input and comment. In stack, the first symbol will be dollar. Now this is the string we are going to input in stack. For the first comment, we will write shift because we will shift this ID into this stack. So this will become dollar ID. Now here it will be plus ID star ID dollar. Now we have to shift this plus sign into the stack, but since ID has higher precedence, we cannot shift this plus sign. So we have to reduce. We will write reduce, and we will write the handle of the ID. In the previous video, I have taught you the handle. So this ID, if you remember the grammar, the handle for this ID is T gives ID. So T gives ID. So we will reduce this ID to T, and then we will shift this plus here. Now here it will be ID star ID and dollar. Now we will shift this ID into the stack. So we will write shift. Now in the input side we have star and ID, but since ID have higher precedence, we cannot shift star here. So we will have to reduce the ID to T. So we will reduce the ID again to T. So we will write T plus T star ID dollar. Now we will have this ID. We can shift this ID into the stack. So we'll write shift. It will become dollar $T plus T star ID. Now dollar has the lowest precedence, so we cannot shift dollar here. So we will have to reduce ID into T again. So this will become dollar T plus T star T. Now dollar will ignore these T signs, and we will see, and it will see this star sign. But since dollar have the lowest precedence of all, it cannot go above star. So we will have to reduce star, and then we will have to reduce plus. At the end, the result will be dollar T. And when you get the result dollar T, because you will reduce this first, you will reduce this T star T to T, because T is the handle of this. You will get the final result, and you will here write accept. This in this way you can do the operator table. So in step 3 we will now create the function graph. फंक्शन ग्राफ क्रिएट करना बहुत आसान है. बस हमें क्या करना है, यहाँ पर f और g दो फंक्शन ले लेने हैं. g फंक्शन लेना है हमें इसके लिए, f फंक्शन लेना है इसके लिए. f फंक्शन में हमें लिखना है यहाँ पर f id, f प्लस, f स्टार, f id और g यहाँ पर लिखना है हमें g डॉलर. सेम हमें g के लिए करना है. यहाँ पर हमें लिखना है कि और f डॉलर. इसके बाद हमें क्या करना है, इसके बाद हमें इन सारे ग्रेटर देन साइंस को एक एरो की तरह ट्रीट करना है. Like here f plus is going towards g plus, so we will connect f plus to g plus. Like here g star is coming towards f plus, so we will go to g star to f plus. ऐसे करके हमें ये सारी चीजों को कनेक्ट कर लेना है. तो हमारा फंक्शन ग्राफ कुछ ऐसा दिखेगा. ये बहुत ही क्लमजी है, बट आप उसको नीटली कर सकते हैं. सो स्टेप 3 कंप्लीट हो गया. बस एक लास्ट स्टेप बचा है, एंड आवर ऑपरेटर प्रेजेंट पार्सर विल बी कंप्लीटेड. Now I have created the neat diagram for this function graph. The last step is to create function table. For this we have to create f and g table, and we have take all non-terminals where it will go. Now this is very easy. You just have to take the longest part for the given non-terminal and its sign. For like example, f plus is here. So with f plus you can go g plus and f dollar. You will not see any other path. So f plus, f for f star, you can see that we can go from f star plus and f dollar, but it is not the longest path. So we'll take the longest path, and we'll write 4 non-terminals we can go through. You can do the same for every other sign and its non-terminal. This is the final answer. Now you can do more example on your own. You can refer to the book Ullman, and you will be exam prepared for operator precedence parser. Operator precedence parser is over for now. We will move towards LR parser in the next video. Thank you, and please subscribe, like, share, and comment.